Good evening, everyone, and welcome to Database Africa's virtual meetup. So if you don't know me, my name is Thembelihle Gumede, and today we're doing a recap of one of the largest AI events of the year, Nodes AI 2026. So just give me a moment and we'll kick off our presentation. So over the next hour or so, we're going to look at how the conversation around artificial intelligence is shifting from just pure hype into building real production systems that actually work for enterprises, and exactly where graph databases fit into this picture. All right. Okay, before we dive into the technical part of this presentation, I want to take a second and talk about this community. Graph Database Africa is by and for developers for the whole continent, whether you're a founder trying to build smarter artificial intelligence systems, or you are a business trying to find better infrastructure, data infrastructure, for your enterprise, or you're just a beginner and curious about databases, then this is the place for you. Africa right now has unique and complex challenges, and we need intelligent and context-aware systems in order to keep up with what the world is building and what the world is releasing out there. So this presentation aims to cover that. Right. So what is Nodes AI? What are we actually recapping on? So last week on the 15th of April, thousands of developers, AI practitioners, executives came together and joined us for a virtual conference called Nodes AI 2026. It was 7.5 hours, and it was dedicated entirely to graph and AI. There were over 40 sessions, and it was divided into 3 tracks. There was first knowledge graphs and GraphRAG, graph memory and AI agents, and then graph and AI in production. So it wasn't just a conference that tells you the what or the why, but also the how. There were also live demos. And should you want to see these presentations for yourself, you can go to Neo4j's webpage under the Video Hub. Then you'll get to see the presentations for yourself. Yeah. So if I could summarize what was covered in one sentence, it would be this: Nodes AI is where the future of AI architecture is being defined. We watched the industry collectively realize that throwing more data into LLMs isn't enough anymore. We need reliable structures for our large language models, for our agents, for anything that touches AI. And this is what was covered during Nodes AI. But before we get into that, I want to tell you why this matters. For the last 2 years, we've seen like incredible AI demos where you type a prompt and you get a nice PDF that covers maybe your FAQs for your company, or gives you some good code in which you can actually deploy a web page. And it looks like magic, to be honest with you, but there's this tension that every engineer, that every founder, that every data professional in any environment has. So it's the gap between a very nice, very polished demo and a production system. A demo can afford to guess and make mistakes. Production systems can't, especially when they touch sensitive industries like health and finance. That is where your AI has to have trust, explainability. You have to see how that AI makes those decisions. since most of the world, including South Africa, is working on frameworks that cover exactly that. Okay, so to bridge that gap, AI needs foundation of truth, so a source of truth that we can point to, right? So there are three big ideas that were covered in the conference. This is big idea number one, which is something called context graphs. If you haven't worked with graph databases or knowledge graphs, I'll just give you a brief breakdown. So usually we see information in like tables where there's different columns and also rows, right? And that's where our data lives. And then when we need information that goes through different tables, we perform joins where we get that information, like we're joining table A with table B and table C, so we can get to certain information. But when it comes to graph databases or knowledge graph, it works in nodes. So nodes, it's like little circles, and then it has connections between those different circles, which are relationships. And in those nodes, it has IDs, it has vectors, it has properties, all of the information that you need for each node. And when you think about it, that's how we learn to process information, even from a small age. We were told to create mind maps if we were coming up with a story, or we needed to flesh out an idea. And that's also how neurons work. Neurons don't work in tables, they work collectively in a network. So that is how information is presented in knowledge graphs. So what are context graphs? Okay, so I'll make an example like this. Think of an LLM as a brilliant intern who suffers from severe amnesia. And we know this is true for AI. AI has a lot of amnesia. Every time you ask a question, they start from scratch. So what a context graph does, it cures that amnesia. It takes a standard knowledge graph and it adds time, which we call temporal validity. So an example with this would be, so you ask the AI, how much does Thembelihle earn? And it says Thembelihle earns 10 million US dollars. But it doesn't tell you that Thembelihle earns 10 million US dollars today. Is it yesterday? Is it 5 years ago? Is it 10 million US dollars from a specific company? So we need temporal validity, which means we need to know when exactly that was true. At what point in time did Thembelihle earn 10 million US dollars? So we need that. That is part of the AI's context. Then we need provenance. So provenance is where the data came from. If you're saying Thembelihle earns 10 million US dollars, did this information come from her payslip, from the company? Did it come from her credit application where she stated she earns that much? Does it come from her bank statements? So where is this information coming from? Then what wraps this all up is the decision trace. So how did that decision get made? How did AI come to a certain decision and when? And why does this matter? Because AI needs a memory, a living memory. So it needs short-term, just like how we think. We need short-term memory, long-term memory, and we need reasoning, so how we comprehend the world and everything. So if you give that to AI, obviously it's going to enhance its performance, right? And the context that is provided to AI also needs to be reliable. It needs to see the world as it is today and understand how things connect, how your data connect, and remember why it made a certain decision. I'm going to go back to a quote from the conference. Let me just make it smaller. So this was the quote from the Chief Product Officer. He said that most enterprise AI behaves as if it has never seen your data. And that is so true because, as we said, throwing large amounts of data is not going to help you. You need to give the agent context so it knows how to reason when it comes to your data. Okay. So how do we bridge the gap? How do we give AI context? So this would be your AI agent or your model. And then how you bridge the gap is by having knowledge graphs. So structured, and this tells you your why, and links it to your actual source data. And then as we spoke about provenance and also temporal validity, and then you get your context graphs. And you replace probabilistic guessing because that's how LLMs work. That's how AI works. It gives you the best answer or the one that's similar to what you're looking for, the one that's maybe 99% probably what you're looking for, but it can't tell you how it got to that answer. Right. Okay. So yes, so this is a diagram that just shows you how semantic similarity looks like, and then compared to graph-powered AI, which tells you how it came to a decision when you can trace it back, that it went through this and this and this and that node and came to that conclusion, how it found the answer. And I think AI that's really good can tell you that it doesn't have certain information, which tells you what gaps you have in your architecture, and then you can go back and fix that, rather than AI lying to you on purpose because it has to give you an answer. Okay, so let's come to big idea number 2, which is MCP and Neo4j. So this is the technical bridge making this possible, right? MCP stands for Model Context Protocol. It's essentially the universal language that allows AI agents to securely connect to external data sources, right? So when you pair MCPs with Neo4j as a memory layer, this is where the magic happens. You move from stateless, forgetful AI to intelligent and systems that have persistent and explainable memory. And yeah, so this is how agents will remember, reason, and critically explain how they came to a decision. During the Nodes AI conference, someone did a demo to compare ordinary AI compared to graph-powered AI, and we found that it uses less tokens. It takes a shorter time to provide you with an answer, and if it doesn't have that data in the memory layer, it tells you instead of hallucinating and lying to you, which is something that is very powerful. So just quickly, this is how I will definitely share the slides at the end. And then finally, the big takeaway was about grounding all of this in reality. Everything sounds amazing when you talk about it in theory, but how does this look practically? So this segment was graph and AI in production environments, in enterprise environments. The sessions weren't about theoretical experiments, they were about real massive deployments and enterprises using this architecture right now. And why would enterprises use this architecture right now? Why would they use Neo4j? Because we are moving to an age where AI, you need to trust the AI that you're putting out there. So build systems that users can rely on, right? And then explainability is the most important factor because it touches your governance and also your compliance, which is what the world governments are working on. they're working on different ways in which they can make AI safer. So if you can explain how your AI makes decisions, then it puts you on the forefront of what is coming when AI becomes fully governed and fully controlled, right? And then scalability. So integration with platforms like Snowflake, Microsoft Fabric, and other cloud infrastructure. Your AI could be absolutely amazing, but if it doesn't scale and it cannot work itself around your existing infrastructure, then it's not really good. It's not something as an enterprise you'll buy into, because you don't want to start from scratch. You want to work with what you already have and make it better. That's the point of artificial intelligence. It shouldn't be hard labor. It should make your life much more easier. Okay. Right. So when AI makes a recommendation based on a graph, you can trace the exact path it took to get there. That explainability turns a risky AI experiment into enterprise-ready product. Yeah. So this is something that they touched on too. It's something we call infinite graph. So the scale is like huge. It can natively handle 100 terabyte plus of fully transactional graph data, zero upscale, and it stores your data in block format. So it's easy to traverse and you use less tokens and less memory whilst doing that. Because you don't want AI to be overly expensive. Okay, so what are the fundamental differences between traditional AI and graph enhanced AI? So traditional AI is stateless, which means it doesn't have a persistent memory. The context is limited, and it starts fresh, like it starts off fresh for every conversation. So you're starting from point A every time. And then with graph enhanced AI, you have a persistent and structured memory layer. You have your short-term memory, your long-term memory, and then your context and reasoning memory. And your AI uses those layers to come to a decision, to come to an output or an answer that you are looking for, right? And it's context aware, and it's aware also of the relationships between your data. That Thembelihle works for Neo4j, not that Neo4j works for Thembelihle, and it knows that distinction because of the memory layers you've created, because of the knowledge graph you've created. Yes, but traditional data only finds similarities between certain data and provides you with an output. Yeah. So what does this mean for you in the audience today? If you're a developer, this is a toolkit to build smarter AI systems that do not hallucinate. If you're a founder, this is how you build your moat. By creating trustworthy products that enterprises will actually buy. And this potential is massive also for small businesses, even large enterprises. So like imagine graph-powered AI mapping complex supply chains in agriculture or detecting fraud. I know everyone in South Africa is having a hard time with certain banks. What if all of those problems could be resolved with using a graph-powered AI, or adding a graph database layer to your existing data, or tracing patient pathways in healthcare. So these use cases that I'm presenting to you, I didn't draw them from thin air, but it's some things that were presented during the virtual conference. There's a company called Kaizen which was able to build something that could help patients find treatment for specific cancers. But it's absolutely amazing. Even here in South Africa, there's a number of banks that use Neo4j as a platform. And I have to say that those banks are not prone to fraudulent activity and also scams. So this tech is really making waves. These platforms are really making waves. In the invites, there were links for like the Neo4j Academy, the GraphAcademy, where you can learn more about how these tools work, how you can build them yourself. And there's also developer documentation. There's also the community. So please go check it out. It doesn't stop here. So we've covered the why and the what. Now it would have been time to cover the how, and I was going to hand over the meeting to Adam Cowley, but the staff developer advocates at Neo4j, but he couldn't join us today. So he was going to do a very great demo of GraphRAG and MCP integrations, since he's actually the person behind building the GraphAcademy. So all the courses that you see, he's a big contributor to that platform. But unfortunately, he couldn't make it today. But now I'm just going to open the Q&A. If you have any questions, if there's anything that you'd like to know, I'd be happy to answer your questions. Thank you for joining us today. Yeah. So now we're just going to start our Q&A. Are there any questions from anyone?
Hi, Thembelihle. Great presentation. Thank you for the invite. And yeah, I'm saddened that I couldn't miss the actual conference, but thank you again. Very informative presentation there. Content, basically. Thanks.
Thank you for joining, Siphohlope. Yes, but don't worry, if you missed the conference, you can always go to the Neo4j page under the video hub. It has all the different sessions, and you can just pick something that piques your interest, and you can go ahead and watch it from there.
Good stuff. No,
Yes.
thank you.